Let's begin talking about algebraic expressions. Let me write this algebraic expression. Now this expression has two terms. X is one term, 5 is another term. Only addition and subtraction separate terms. So if I have, for example, 2x, that is a one term. That's a multiplication. So multiplication and divisions do not separate terms. Now if I want to translate that, you can write that in English. You can say what? X plus 5. Some people might write that x increased by 5. Other people might say what? The sum of x and 5. Other people might say what? 5 more than x. So in a few minutes we're going to start looking at word problem and changing it to algebraic expressions. So you want to look for these keywords. Look for the word plus. Look for increased. Look for the word sum. Look for more than. All of these imply addition. So these words, all I'm telling you, you have addition. On the other hand, if I write, for example, x minus 4, I can say that x minus, the way I wrote that, 4. Instead of increased by 4, this will be what? X decreased by 4. Instead of the sum, it will say what? The difference. The difference between x and 4. Or they might say 4 less than instead of more than. Less than x. Again, these keywords, I'm going to underline them. Minus, decreased, difference, less than. All of them imply you have subtractions. So when you look at a statement in a few minutes and if you see plus, that means increased or addition. Increased, that means addition. Sum means addition. More than means addition. If you see minus, means subtraction. Decreased means subtractions. Difference means subtraction. Less than means subtractions. Now let's try that the multiplication and division, see what keyword you might be looking for. Because where we're going is right there, translation. How do you take a sentence and change it to an algebraic expression? Basically, we're talking about word problems. And you know that's everyone's favorite topic. So what about if you have multiplications? I have, for example, I don't know, I'll make a fraction. 2/3 m. That means what? 2/3 times m. A lot of times we don't put the dot. Actually, 90% of the time you will not see it like this. You'll see it like this. Again, this means 2/3 times m. Or the product of 2/3 and m. Doesn't matter which one you write first. You can say the product of m and 2/3. Also in math, the word of, 2/3 of m. Of means multiply. So times means multiplications. Product means multiplication. Of means multiplications. So times, product, of, all of these imply you have multiplications. And we'll do one more for division. T divided by 2. You can write that T over 2. So again, you just heard me say one of them. T divided by 2. The quotient. Quotient means division. When you write the quotient, you always want to put this one first and this one second. The top one first, the bottom one second. The quotient of T and 2. Not 2 and T. T and 2. If you write 2 and T, 2 on the top, T on the bottom. So this one, the one you write first, is always your top number. The one you write second is always your bottom. The ratio. Ratio means division 2. Ratio of T and 2. Or sometimes we use the word 2, or in this case T. Where's my eraser? T over 3. Some people will say T over 3. So again, these words here, all of them imply you have division. Over, ratio, quotient, divided. So let's practice some of them. Let's take some of them and practice. Here we go, some examples. If I write 1/2 P, I'm going to put the translation on this end. This is the algebraic expression here. Doesn't look straight. Looks disgusting. Try to be a little bit neat. I'm going to write the same thing. I just want to make it look neat at least. Attempt to make it look neat. There we go. So here we're going to write the algebraic expression. And on this side, we're going to put the translation. So let me begin with the first one. I wanted to write 1/2 P. I can write that. That's a multiplication, right? So I can go through my list for multiplication. I can say 1/2 times P, the product of 1/2 and P, or 1/2 of P. I'll go with 1/2 of P, no reason. It's a multiplication, so I can use one of these. 1/2 times P, 1/2, the product of 1/2 and P, or 1/2 of P. The next one, I'll do a few of them. 9 minus x. Let's look at subtractions. Choice words for subtractions. Minus, decreased, the difference, or less than. It's up to me. I can choose any one of them. I'll mix and match. If I'm going to use this one, decrease, I'll say 9, because that's the first one. 9 decreased by x. Not x by 9, 9 by x, because I wrote the 9 first, x second. I'm subtracting x from 9. So I'm going to lower 9 by x amount. Or I can say the difference. Missing the n here. Between 9 and x. The difference between 9 and x. N plus negative 6. That's addition. I can use n plus negative 6, n increased by negative 6, the sum of n and negative 6, n or negative 6 more than n. So I can use any one of them. So maybe I'll take the shortcut n plus negative 6. I can use any one of them. I'm just choosing one. No reason why I pick this over the other choices. Now let's make them more complicated a little bit there. Because in a few minutes we're going to work backward. We're going to go from this to this. That's really what the key. That's what we're going with. How do you go from here to there? Let me write this one. 2x minus 3y. Let's look at the first one. 2x. How do you write 2x? That's a multiplication. Well, not sum. Sum means addition. So we have a multiplications. I can say 2 times x, right? The product of 2 and x. 2 of x sounds silly, 2 of x. That doesn't sound right. When it's 2, a lot of times we just write twice x. Or 2 times x, twice x. Now we have subtractions. Subtraction, I can say what? Decreased by or minus. I'm not going to say the difference. I already wrote 2x. Otherwise, I say the difference between 2x and 3y. I could use that, but I already wrote twice x. So it's either going to be minus or decreased. I can say minus. And now I got to say 3y. That's multiplication. I can use times. 3 times y. Twice x minus 3 times y. Or I can say the difference, if you want the difference, between 2x and 3y. The difference between 2x and 3y, or 2 times x and 3 times y. Maybe I can grab another one, steal another one from the book here and see what we're going to put there. Five times, let's make something up, a minus b. I can say 5 times, that's a multiplication, times what? What do we have here? Subtraction, right? 5 times what? The difference between A and B. 5 times the difference. This is the difference between A and B. A minus B. And 5 times that. Maybe one more. I got room for one more. How about this one? R minus S over R plus S. Division. Division, where are they? I can say divided the quotient ratio over. If I want to use the quotient, I'll say the quotient, that means division, of what's on the top. What do you see on the top? Subtraction. So how do we write subtraction? Minus. We'll say the quotient of the difference between R and S and the quotient of this and this. So this piece here, that's the top. See that? That's the top. All of that is the top. And now is the bottom. What's in the bottom? The sum. What happened to S here? I forgot the S, huh? R and S. And what's in the bottom? Don't we have the sum? The sum of R and S. So that's the top and this is the bottom. The quotient, which means division, of this piece and that piece. Okay, so that's the translation. This algebraic expression, we can go back and forth. Soon enough, you'll see that. We have one more topic. When I wrote the headline for section 1.6, I said algebraic expressions, translation, and exponents. So let's look at the exponents. We're still in the same section. Exponents. If you see, for example, 5 to the 4th, the 5 is known as the base, and the 4 is known as the exponent. That's the exponent. So when you see 5 to the 4th, what does that mean? Does that mean 5 times 4? No. Then what is it?
5 multiplied by itself 4 times.
Good. Multiply the 5 by itself 4 times. 5 times 5 times 5 times 5. 5 times 5, 25 times 5, 125 times 5, 625. If you see 2 to the 10, that's not a 20 either. That's what? 2 times 2, how many times? 10 times. Four times 2 is 8, times 2 is 16, times 2 32, 64, 128, 256, 512, 1024. If you multiply it out.
Surprised, the math teacher's really good at math.
Better be. If I see 3 to the power of 5, 3 times 3 times 3 times 3 times 3. 3 times 3, 9. Times 3, 27 times 3, 81 times 3. Is it 243? How about this one? 4 to the 0. Try again. I heard 0. I said try again. 1. If you have a calculator, try it. It'll give you a 1. 5 to the 0. 1. 10 to the 0. 1. 0 to the 0. I heard 0. Try again. I heard 1. Try again. Very good. Does not exist. If I take my calculator, which is I have one here, and I show you. Here we go. Can you see it on the screen? 10 to the power of 0. That carry this power. It should give me 1. 5 to the power of 0. Should give me 1. 0 to the power of 0. Error. Can't be done. What about negative numbers? What's negative 5 to the power of 0? Basically, anything to the 0 power is 1 except 0 to 0. I heard it's a 1. Anyone second that?
Sure, I'll do it.
Okay, you're both wrong. Come on. That's actually a negative 1. I just finished saying anything to the power of 0 is 1. Well, there's no multiplication, it's just a number. Here's the difference between these two. This is a 1. Anything to the 0 power is 1. You're right. But here, what is raised to the 0 power?
Negative.
Not the negative, only the 5. If they wanted the negative, they would write it like this. So in this case, only the 5 is raised to the 0 power. What's the answer to 5 to the 0? 1, and the man is still sitting outside. That's why this is a minus 1. Notice if I go to my calculator here, and this is a smart one, clear, negative 5, no parentheses to the 0 power, it gives me a negative 1. It knows only the 5 is raised to the 0 power, not the minus sign. Now, if I want the minus sign, I better put them in parentheses. And that's a 1. So there's a difference between them. So minus 7 to the 0 power. This is raised to the 0 power. Not all of them, just this one. That's a 1. And you have a minus sign sitting in the front. That's why it's a minus 1. Minus 7 to the 0 power. That's all of that raised to the 0. And that's a 1. I think that's what you're talking about when you have negative 2 to the 3rd power. What does that mean? Negative 2 times what? Negative 2 times a negative 2. How many minus signs do you see here, or negative numbers? 3. That's an odd number. If the result is odd, if you have an odd, the result is what? Better be negative. Let's see if we get a negative answer. What's minus 2 times a minus 2? So that'll be a plus 4 times a negative 2. What's a positive times a negative? Negative 8. Sure enough, it is negative. If I have negative 5 to the 2nd power, the whole thing to the 2nd, that's negative 5 times negative 5. That better be positive. Even number of negative signs always produce positive result. That's plus 25. Here's the problem. If you write like this, the answer on our software, they'll mark it wrong. They don't want to see the plus because they want the answer simplified. If there is no sign, it's assumed to be positive. What's negative 2n times n?
Negative 3n.
Negative what?
3n.
Why 3?
It's negative 2 and then just multiplying that by n again.
Well, what you're looking at is actually negative 2 times n. That's what negative 2n
To the second power.
times another n. That's what that means. What you did, you were adding. So look at these two. What's n times n? How many n's do you have here? 2, right? So that's negative 2 times how many n's? 2. I don't need to put the dot here. For multiplication, we never put it. That's negative 2n squared. Just like if you have this, negative 3x times x times y times y times y. I can break it down to negative 3 times x, the first one, times x times y times y times y. Look at the x times x. How many of them? 2. X squared. Y times y times y. How many of them? 3. Y to the third. We don't have to put the dot between them. We know it's multiplication. And what do we have left in the front?
Negative 3.
Negative 3. So negative 3 x squared y to the third. Now if you look at these exponents, if you look at them, what is the power of x here? 1. What's the power of x here? 1. If there's no number, it's always a 1. So notice to get y to the third, you don't multiply these because 1 times 1 times 1 will give you what? 1. But if you add them, what's 1 plus 1 plus 1? So when you multiply, you really add your exponents. 1 plus 1 plus 1, that's 3. 1 plus 1, that's a 2. So you'll see that when we get to exponential notation, how do you multiply them? You know?